questions do we have? Want to go over on the chart guide? See a lot of ones and more. I was going to say more threes and twos, so we'll do those three. These two can be done in Desmos. This one can be done in Desmos, but because you have the graph, it's just easier to use the graph. So let's do those two first. So because this is something we could put in a table, you have to just read it as whatever x goes with whatever y, put that together, so -2, 1, 3, 0, 7, 1, 7, 4. And then in that, I could see that this does not make a line that goes through 0, 0, so not direct. It makes a curve, but it's a weird one, and it's not the one we're looking for, so not inverse. But also, if we did this algebraically and we multiplied to see if it was inverse, we wouldn't get the same number. If we started dividing y over x, we again wouldn't get the same number. So neither for that one. Number 2, we could put that into Desmos using either the capital letters, putting it in parentheses, using a different variable. I'll just use parentheses for today. So if I put in -4, wherever I see an x, we get 16. Questions on that one? Yes.
Why is there another -4?
Which one are you talking about?
The one in the back. Like at that.
Because it's 12 times x, and x is -4. Right, and then number 3, if I had to write the equation of this given line, if this line were to continue. If I'm looking at the points, I can see that this has a slope of 2, or should, if it continued. So I know, or -2. If I kept going down 2 to the right one, I would end up at -2, so my equation would be y equals -2x minus 2. If you were to do that in Desmos, you'd have to find a point that it goes through, put that into Desmos, type in your y equals mx plus b, change the m to -2, and then move it so it goes through that point to find your new y-intercept. Take out your notes from last class on multiplying and dividing exponents if you don't already have them out. Didn't do this or didn't do a good job of this last time. Once we figure out the rule, we're trying to do expanding less, try to stop expanding, and just apply the rule to this. So we're going to be doing that same thing for the next 2 pages, trying to figure out the rule, expand it, and then once we figure out the rule, stop expanding it. Did we have any other questions on this case that we wanted to see Jim go over using the rule before we go on? Alright, so then we'll start off with expanding, but our goal is to stop expanding, figure out the rule that will help us to stop doing that. So if I had x to the third to the fourth, that would be the same thing as saying x to the third times x to the third times x to the third times x to the third. 4 times. as we already know the multiplication rule, if we are multiplying like bases, we add the exponents. So that would be x to what power? If I were to expand number 8 and do a to the negative fourth 7 times, we have to do a couple things. You could either add the exponents together and then flip it, or flip them each and then add them. It's your choice, really. Let's say we added them all. What would that new exponent be?
1.
You're really adding negatives.
1.
Negative 28. And then we can't leave this like this, so how could we rewrite that?
1 over a to the power of 28.
1 over a to the power of 28. Anyone seeing what the rule might be to get from here to here? Not adding.
Multiplying.
If I multiply 3 and 4, I get 12. If I multiply negative 4 and 7, I get negative 28, and then I have to flip it. The negative exponent rule says when you have a negative exponent, you flip it.
So I change the sign on the exponent too.
For the negative exponent, yep. So your rule for powers of exponents, when you raise an exponent to another exponent or to another power, you multiply the exponents. Are there any others we want to see on this page using the rule? Max?
11.
11.
Is 10 just what you do every other one? What would you do with the numbers? The number 2.
We could do that one. It'll be similar, but we'll see a repeat in 11, but you'll see. So for 9, think about this like your order of operations. You have to do what's inside the parentheses and then do your exponents. So here we have to multiply these two exponents first. And now that we are just multiplying like bases, what are we doing with the exponents? Adding them, but in this case adding a negative or subtracting. So c to the 5th minus 6. If you want to write it like this and then simplify it, you can, but this is not a necessary step. So this would be c to the negative first. We can't leave it as a negative exponent. How would we rewrite it?
1 over c.
1 over c or 1 over c to the first. Either one. Questions about that one before we do 10? For 10, we are still doing that same thing, multiplying the exponents, but you have to remember that these are two separate things. This has an exponent of 1, and you're really going to multiply that 3 to every exponent. Think about it like distributing, but just to the exponents. So multiply the 3 to the 1 and to the 2. So that both things get affected. Then you could simplify what is 2 to the 3rd. Questions on that one? So while while we are trying to use the rules to help us make this process go a little faster, you are always welcome to go back to expanding. But especially when you're raising powers to powers, you could get a bunch of things and have a lot of things and maybe miss one, miscount. So be careful there. Okay. 11, same thing. Multiply whatever's outside to the inside exponents. The 4 we get multiplied to both exponents of 3 and x and y. We have x to the negative 4th times 3 to the 4th, x to the 4th, y to the 8th. Multiplying, not adding here. Then we have like bases, our x's, and we can simplify the 3 to the 4th. So if we have like bases that are multiplying, we can add them, but negative 4 plus 4 is 0. So I'm going to write that for now. 3 to the 4th is what?
81.
And anything to the 0 power is
1.
So this would just become 1, which means this is just 81 y to the 8th. The y disappears. The x disappears, sorry. So sometimes your variables disappear. You start with 1 and now it's gone. But sometimes you do that by accident, so be careful.
Why did the second?
It was supposed to be at 8, but the 4 didn't want me to write this time. Other questions on this one or this page?
What is the x discipline again?
Anything to the 0 power is 1.
Oh. And also, what is the x with negative 4?
So we added our like bases to get that 0. Max.
Please, on number 10, why do not multiply the 8 x's?
They are being multiplied. They're multiplying right now.
So like, why don't we do that?
You mean instead of applying the 6 here? Because these are 2 different things. This is the next one of 1. If it was like this, then we would do that. Alright, go on to the next page. So we're going to do one example, see if you can figure out the rule. You could probably guess what it is without us doing it, but we'll still do one expanded version. We're trying to figure out how could we do this without expanding, but we will expand for 1. So a to the 6, we would write that out 6 times. A squared, we write that out twice. And then we could get rid of anything that is the same, so 2 of them would cancel. What do we think this rule might be?
Subtract.
Subtract. When dividing like bases, we subtract the exponents. So here I could have just did 6 minus 2 is 4. So let's write that rule down. When dividing like bases, subtract the exponents. And then look at this page, find some examples you want to see, do, go over, have questions about. Jackson.
15 and 17.
15, 17, Ella. 18. Okay. Can I see the example? We won't have time to do all 4 of these. Maybe. We'll see. So for 15, you have choices as you start to simplify these. If you see negative exponents, you want to get those out the way and swap places and deal with that first, do that. If you see like bases and you want to subtract here first, do that. It doesn't matter. You should get the same answer either way. So let's say that we just focus on like bases. I have x's, I have y's, I have c's. once you get the hang of this, you won't need to write what I'm about to write, but I'm just going to write it so that you see that we're subtracting. We have x squared minus 1, y to the negative 1 minus 4, z to the 4 minus a negative 3. You could just subtract it and write what the new things are and then flip it. So simplified, we have x to the first, y to the negative 5th, z to the 7th. So x and z are going to stay in your numerator. Y is going to get changed, moved to the denominator. If you wanted to write this as the flip version and then condense it, you can also do that. There are different ways to go about doing these. Questions on that one? We can do 16 and then that'll be it. So here we have something where we have a fraction and it's being raised to an exponent. This one really shouldn't be in this one, but that's okay. Each thing inside has an exponent of 1. You're going to multiply both by 3 and simplify both pieces. 4 to the 3rd would be, and 5 to the 3rd would be, and if that could be simplified further, you would do your alpha y equals, put that in, see if it will, but this will not. We'll go to 17. For 17, similar to 16, again, this is one that really doesn't need to be here, but we're going to take the 3 and multiply it to all of the exponents on the inside. So this would become 4 to the 3rd, x to the 3rd, over y to the 6th. 4 to the 3rd we just figured out was 64. So that would be 64 x to the 3rd over y to the 6th. Questions on that one? With 18, if you're using your order of operations, you can do one of two things. You can either simplify what's on the inside first and then distribute the -4, or you can distribute the -4 and then go with whatever's left. So I'll show you that both work. So if we were dealing with what's on the inside, I have like bases. We're going to subtract those. 5 minus 2 will give us 3. You have another set of choices here. You can either take this whole thing and flip it, leave it in parentheses with a positive 4 outside of it, or you could apply the -4 to each thing and then flip it. It's up to you. But let's say I took this and applied it to everything here. We have 2 to the -4, m to the -12. And then both of those would flip together. 2 to the 4th, m to the 12th. And 2 to the 4th as well. Calculate it.
16.
Not 8, because you're not multiplying, but 2 times 2 times 2 times 2. 16. Oops. 1 over 16 m to the 12th would be that final answer. I'm going to show you that the other way would work, and then if you guys have any questions, and then you'll have some time to practice, and then we'll come back and move on. So let's say I apply the negative exponent to everything. Also, you could also take the whole thing and flip it and make the exponent positive, but that gets a little messy. So let's say I applied the exponent to everything, so 2 to the -4, m to the -20th, over m to the -8. And then simplified the m's, or subtracted our exponents. Negative 20 minus a negative 8 would give me negative 12. This is negative 20 minus a negative 8, not negative 20 minus 8. And then we see we're at the same stage, so the rest would be the same. So either way, that works. Questions about that one? Okay. Go on to the next page. We're going to review all of your rules really quickly before you have some time to practice. So if you get stuck, you can refer back to this. It's a good way to help you strategize what to do next. If you see a number raised to another power, distribute or multiply that number to any exponents inside. If you would like to move like bases together, feel free to do that. By, let's say if they're all multiplying, you want to move like bases together, you can do that. They're just supposed to say multiply. If you see like bases and they're being multiplied, add their exponents. If you see like bases and you're dividing, subtract the exponents, sorry. If you see negative exponents, move them from either the top to the bottom or vice versa. And then if you have coefficients with just numbers 2 to the 4th, negative 3 to the 3rd, whatever that is, actually simplify those. And then it doesn't say this, but anything to the 0 power is 1. Right? So on the next page, I want you to do as many of these as possible in the next, I'll give you like 15 minutes to work through as many as possible. If you guys can work together in that 15 minutes, you can move around. I'll be walking around if you have questions, and then we'll come back and do go over. Have questions about 11? 11, okay.
7.
We're not doing all of them. 7. Okay.
It's just 24.
You said 24?
Yes.
And
24.
you're not doing all of them. 20, yes. 14.
15
And you can
plus 4.
do 6. Okay, let's stop here. So starting with 2, if we were using our rules, we could multiply the numbers out front, so that would be 8, and add all the exponents since we have the same like base. So 5 plus 4 is 9, minus 1 is 8. Questions on that one? Okay. 6. We can multiply the two numbers, combine your exponents by adding, so 3 plus 0 is 3, negative 4 minus minus 1 is negative 5, and then we have to switch the negative 5, we can't have negative exponents in our final answer. So 36 x to the 3rd over y to the 5th. Questions on that one? Now, if you had changed the x to the 0 to 1, you'd still get the same answer. So how you do that is up to you. Number 7, multiply the 2 and the 5. Combine your x's, so that would be negative 8. Combine your y, so 5. And the z doesn't have a like base. So it just stays 5. And then the x gets brought down. Make sure you aren't bringing down the number with it. These are next to each other. They're multiplying to each other, but they're not connected. So 10y to the 5th, z to the 5th over x to the 8th. Questions on that one? 10, if we multiply 0 and 4, we get 0, which is 1. Anything to the 0 is 1. 11, we have to multiply the 6 to both exponents. So we have x to the 6, y to the negative 24th, multiplying, not adding, or subtracting. And then move the y down. Questions on that one? Okay. 14, same thing. Apply the negative exponent to everything, or you could take the whole thing and flip it, make it 1 over all of that to the 4th, up to you. So if I just applied it as is, we have 6 to the negative 4th, x to the positive 12th, y to the negative 8th. So 2 of these things are going to move down, x is going to stay in the numerator. Someone tell me what 6 to the 4th is.
Isn't that 16?
No.
1,269. 1,296.
1,296. Because it's 6 times 6, which is 36, times 6 again, which is something in the hundreds, and then times 6 again. Questions on that one? 20. We're dividing. We're going to actually divide the numbers to the best of our ability. If we can simplify it, do that. If it can't be simplified, leave them. So 3 over 6, we know is 1/2. We have like basis for x's. Negative 2 minus a negative 6 would be a positive 4. And we already have y in the denominator. I just separated like this so you could see what each piece is doing. But now I'm going to write it as one condensed fraction. So x to the 4th over 2y to the 6th would be that final answer. Questions on that one? Justin?
Where'd you get 4?
Negative 2 minus a negative 6. The negative and the minus become a plus. And then 24, the 3 and the 5 couldn't be simplified more, so those stay the same. The h is going to come down and it doesn't have a like base. So I'm going to write it like this for now. The j's can be simplified. 4 minus 1, we get j to the 3rd. Negative 6 minus 1 would be negative 7. So that's going to get brought down. J is going to stay up. I don't know why I started writing it like that. So 3j to the 3rd would be in our numerator. K is going to come down, so 5h squared k to the 7th. So 3j squared cubed over 5h squared k to the 7th would be your final answer there. Other questions? Were there any other like pressing, I really want to know this answer, or I did this problem and really want to know this answer? That's
4. Oh yeah, wait, no.
18.
Similar to 20, the 3 divided by 6 would give us 1/2. If we subtract the exponents, that would just be r, or r to the 1st, and that's going to go in the numerator, condense it. So it can be r over 2 or 1r over 2, either or. Go on to the next page. We're going to do some of this today. today, finish the rest next class, and start the next Tuesday. Alright, I want you guys to look at numbers 1 through 8 first. We'll talk about the other ones after that. Any of those we want to see, do go over, have questions about. Three. Any others? Okay.
4.
Anything else? We'll start with those two. If we have other questions, we'll do that. So number 3, I want you to tell me what operations you see. Multiplication. So we are multiplying. Do we have like bases?
Yeah.
Yes, the x's. We're multiplying like bases. What are we doing with the exponents? Adding. And we have just numbers, so strictly multiply those. If we add the exponents, what would that new exponent become? -1. Would this be my final answer?
No.
No. How could I change this?
Negative.
Flip it.
-8 over x.
So we have -8 over x or x to the first, either or. So these are all the questions you should be asking yourself. What do I see? What could I do? What rule is that? Questions 1 through 3 before we do 4. What operation do we see there? Dividing. We see subtracting.
No.
We're going to subtract. Okay. Any other operations? Multiplication. Now, in our multiplication, we don't have anything that are like bases, so we don't have to worry about adding the exponents. But we are dividing, and we are going to subtract the exponents. We are also going to divide 5 over 20. What would that give us? 1/4. If we're subtracting our exponents, 8 minus a -2 would be 10. And 1 minus 6, 5. And then when we rewrite this, what would that final answer be?
X to the power of 10 over 4y to the power of 5.
Yes. X to the power of 10 over 4y to the 5th. Do we have any questions on that one? Are there any others in numbers 1 through 8 that we want to see you go over, have questions about? Look at numbers, whatever is down here. 1 through 5. Any others? Jackson. 3. So let's try both of those. So what operations do we see there? Multiplication. So we're going to add. And what about this? We will be multiplying. We're raising a power to a power. Okay. What should we do first?
Do this parentheses with this should be good.
Distribute, multiply together, sure. So take the number outside and multiply to all of your exponents on the inside because we don't have like bases inside the parentheses to combine. Don't forget about the exponent of 1 with the 4. So we have a to the 15th, b to the 10th, 4 to the 2nd, a to the -6, b to the 12th. Now what? what did you say? You could move them together if you want. You don't. It's not a necessary step.
We should probably find 4 to the power of 2.
Sure, we can do that. 4 squared is 16. Put it out front. Then what do we do here with the rest of everything else? Not distribute. Combine them by doing what? Adding the exponents. So 15 plus a negative 6, or 15 minus 6 would give us 9, a to the 9th, and then 10 plus 12, a to the 22nd. 16, a to the 9th, b to the 22nd. Stuff like this, b to the 22nd, is why we don't want to expand it forever. Because imagine writing 22 b's. It would be a lot. Questions on that one before we do 5? That'll be the last thing we do today. Unless we have other questions here. Okay. What do we see going on in 5? We're multiplying, we're dividing. Any other? We will be adding the exponents. Distributing to multiply the exponents. We're raising an exponent to another exponent. What would we do first? Multiply the exponent to the other exponents. I'm going to rewrite 3 to the 4th, a to the 12th, b to the 16, over 9a to the 5th, b to the 9th. Now, this is an extra step, but we know 3 to the 2nd power is 9. If you wanted to, you could change this to 3 squared and just deal with those exponents. Or you could figure out what 3 to the 4th is and divide it by 9. You'll get the same answer either way. It's up to you. What is 3 to the 4th? 81. We're doing what with these exponents?
Adding. No, subtracting.
Subtracting. There we go. So this would be a to the 7th, b to the 7th over 9. And if we divide 81 over 9, 9. So this would just be 9, a to the 7th, b to the 7th. Do you have any questions there? Any other questions in 1 through 5? Hold on to these notes because on Friday we will cover the last 3 of simplifying exponents, and then we're going to move on to scientific notation, which you may have seen previously. We just have to talk about it again. And then on to polynomial operations. So for the remainder of class, you will be using it to continue working in these notes. Work on the 2 delta maths that are due on Friday. At this point, you should be able to do both, all of the things in both. And then in about 10 to 15 minutes, I'll have you guys put your calculators up.